One way to secure network traffic is by using the IPsec protocol suite. So IPsec is really a collection of various network security protocols that we're going to talk about here. And it's important to know them for the Security Plus exam because they serve different security needs. Remember the security triad, CIA, confidentiality, integrity, availability? Well, really with IPsec, we're focusing on confidentiality through encryption and integrity through hashing and authentication of network messages. So we're talking about encrypting and verifying that messages haven't been tampered with when sent and received over a network. Now, the cool thing about IPsec is that you can configure IPsec on two different endpoints or on all endpoints on a LAN, all devices if you wish, to encrypt all network traffic, or maybe only encrypt some of it, or maybe only enable authentication for some traffic or all. As you can gather, there are many different ways to enable this. But what's neat about this is that when we authenticate the two communicating endpoints to secure the connection over the network, there are different ways that that connection can be secured. Using authentication protocols that we already know about, like Kerberos, think Active Directory, or using authentication protocols like NTLM v2, think Windows Workgroup computers, using PKI certificates to authenticate parties with one another so they trust each other to communicate securely, or the least secure method, but it still can be used, a pre-shared key, a PSK. If you think back to Mike's crypto discussion in chapter 2, really he was talking a lot about different keys, like asymmetric versus symmetric keys. A pre-shared key is a symmetric key. The same key is used on both ends of a connection for encryption and decryption. IPsec can be configured to run in what's called tunnel mode. And this is normally what you'll see in a site-to-site VPN that links, for example, branch offices over the internet and encrypts everything sent through that encrypted tunnel. So the idea with this is we have an entire original packet. Let's say this piece of paper represents a single packet. Now, if it contains sensitive information, we probably don't want to send it out on its way on the internet as it is. It might be captured and then potentially the data compromised. So what we can do with tunnel mode is we can encapsulate this. That means that what we're doing is we are placing that original packet inside of a new packet, hence packet encapsulation. Now this new packet is going to have new packet headers with addressing information to send it to the other endpoint on the other end of the site-to-site VPN tunnel. So what happens on the other end is we get the reverse process, where on the other end of the VPN in tunnel mode with IPsec, the endpoint device will strip away the new packet headers that were added to reveal the original encapsulated packet. So when it gets to the other side of the VPN tunnel, it's no longer protected beyond that second endpoint. But IPsec can also be configured in what's called transport mode. Now, this is normally what you would use, for example, if you wanted to secure communications on a local area network, perhaps between some internal client stations and a server that has highly sensitive data. You might enable IPsec just for them. So the idea being that the original packet header doesn't get changed and there's no encapsulation like there was in our previous example with tunnel mode. So with transport mode, we're talking about protecting traffic by encrypting it. So what we achieve here is data confidentiality, part of that CIA security triad that we talked about. Another configuration is to use an authentication header, otherwise called an AH. The idea with authentication, if we think about it, is we need to make sure that what we've received over the network is what was sent, that it hasn't been corrupted, it hasn't been tampered with. So this doesn't provide confidentiality unto itself. That's encryption. This is just authentication. Is it an authentic message that has not been modified? So this is done using various types of hashing algorithms that Mike talked about way back in chapter 2. Things like HMAC MD5 or HMAC SHA, SHA, hashing. So the idea here is the entire packet then is hashed and then authenticated on the receiving end. We know how hashing works because Mike told us. When we generate a hash, we have a unique value that represents the state of, in this case, the network transmission before it's sent. When it's received, if we perform the same mathematical calculation, if nothing has changed, hasn't been tampered with or corrupted, we should get the same hash. Otherwise, if we get a different computed hash on the receiving end, something has changed. It's not authentic, it's been corrupted, it's been tampered with by a malicious user, or something along those lines. That's authentication header. We can also configure IPsec for encapsulation security payloads. So again, with the packet encapsulation. But this one is a little bit different, this mode of IPsec, as they call it. So we get integrity and origin authentication. Okay, so for the original packet, it's hashed, and we have a way to verify that it's not been modified on the other end. But we also get confidentiality through encryption. But what gets encrypted is not the entire packet, only the payload inside the packet, the data. Remember that a packet has a number of headers, which is really like just addressing information that you might find on a physical letter that you mail. So what gets encrypted with encapsulating security payload is just the data within it. So that means that we can't read what is inside that packet, which is the point. It's protected through confidentiality. Now, it's one thing to talk about it. Let's take a look at a packet capture where encapsulating security payload, or ESP, was part of that packet capture. Okay, so here in Wireshark, I'm in my packet capture. Now, when we normally select a packet, let's say a TCP-based packet, you might recall that we can view the packet headers. Here's the Ethernet header with the MAC address info. Here's the IP header with the IP address info. And in this case, here's the TCP header with port information and so on. But why don't we take a look at an ESP packet? So I'm going to filter for ESP at the top here in Wireshark, and I'll press Enter to apply the filter. So notice we have a number of ESP captured packets. I can select any one of them and look at the packet headers. But wait a minute, this is different because I still see the Ethernet header. Okay, I still need to be able to see the MAC addresses to get that transmitted around a LAN. We still have the IP header visible. Well, yeah, because otherwise, how would routers be able to know how to route it around the internet? For example, if it's being routed around the internet, you need to be able to see IP addresses for routers or devices to realize it's for them. However, after that, all I have is encapsulating security payload as the next level header. What? So how do I know if this is a TCP or UDP packet? How do I know if it's FTP or HTTP or what it is? You don't, and that's the point. The point is that it's completely hidden. It's been encrypted. You don't even know what kind of traffic it is. But if we put two and two together and say, okay, that's a good thing, but could it also be a bad thing if I have a firewall that is based on TCP or UDP port numbers? It won't be able to read that here. That's correct. So you have to think about more than just the current item that you're configuring when it comes to this type of thing. You need to think that if you're going to enable ESP for the benefit of encrypting packets, that's great. But sometimes those packets won't make it through a firewall if they need to, because the firewall can't read the port numbers to say, yeah, you're allowed or not allowed. So make sure that when you think about IPsec, you think about how it can secure at the confidentiality or encryption level, the message integrity or authentication level, but also the fact that depending on how you configure IPsec, it could cause problems with firewall traversal.